It's Saturday morning here in Hong Kong. It is early December and the factory is empty. We just yesterday received the last two critical parts we were waiting for so we can restart the factory on Monday. And here you can see there's 20 machines all lined up that we're going to build. This is the version 1.1 machine. The factory has been closed since about September when we finished doing all the version 1.0 machines. There are a bunch of changes in this version 1.1. I'm going to walk you through the factory now and show you the various parts and how they fit into making a decent espresso machine. This here is our chassis. It's made all of aluminum and it's all welded together. Everything fits into it and it holds the whole machine together. This here is our water uptake assembly. It's got two tubes. The large one sucks the water up and it's got a particle filter on the end that you can remove if you ever get cat hair or something else stuck in it. The small tube here is our water pressure level sensor. What it does is it measures a column of air pressure here in order to tell how much water you have, which goes into a tube to this little circuit board here, which then digitally talks to the main board to give the water level. Every tube and every wire has a unique color. That makes repairs much easier. This here distributes the water that goes onto the coffee puck. This is where the water comes out, but as it comes in, you can see this is a calibrated maze. The idea behind this is that at different flow levels, the water will go into different holes. First starting on the outside ring here in the middle, outside here, and then at each flow rate going closer and closer toward the inside. The idea is to have a guaranteed even flow no matter what the flow rate is. The other hole is for the temperature probe that goes all the way through the entire group head and rests right behind the shower head about 2 millimeters away from the coffee grounds themselves. That way we're able to sense the temperature of the mix of coffee and water and adjust the water temperature accordingly. This stack of black PCBs is also new to version 1.1. What we've done is use this piece of precision fiberglass to space the brass from the portafilter. Now the reason we did that is we have two concerns. One is we want to get that portafilter to fit just right, and because it's fitting in a thread, getting the exact height is not easy. So we've made a whole bunch of different height versions of this to get it right. But also if you've got wear and tear or if you're using a different portafilter, all you need to do is change this one part and the fit of your portafilter in the group head is then adjusted. This section here is we make all our cables. One by one here are machines. This machine here is for cases where you cannot solder things because the heat would damage the component. So for example, here I've got a thermostat that cuts off power when it gets too hot. If you were to solder something on the wires here, you would damage the thermostat. So to put a wire onto this, you have to take this copper thread, and this machine here wraps the copper thread extremely tightly onto a thermostat. This machine here will very accurately cut a spool of wire or tubing down to the same millimeter length and spit them out. This version of this machine is a hot version, so it can be used for wires like this, but it can also be used for tubes like this. So for all the internal connections where we don't have an end, it's just a raw piece of plastic, that's what this machine is used for. We also use it in order to give you the right length tubing for your catering or plumbing kit. That mountain behind me is the Espresso Suitcase. That's what we ship our machines in. And right next to it are our chassis all bundled up, ready to get made. This here is a place where we pull all the connectors together to keep things simple. You can see that it's actually labeled for steam, hot water, and various things. So those are all temperature probes that go in there. And these holes here are all ends of valves, and we push the whole thing over, and then we have a single soldered connection rather than having a lot of cables. It's much more likely to withstand thermal cycling as well as shipping damage. This here is a steam heater that's in the process of getting made. You can see there's a thermostat on it, and we have a fiberglass box that we make that goes around it. Once that fiberglass box is made, we then stuff the inside of the box here with mineral wool. That all gets sealed up into a box like so. And then inside here you've got a thermostat, you've got two thermal fuses for safety. This orange cable coming out is a temperature probe, and the water goes in from the bottom, out from the top, And then these two red ends are where the power goes in. This is how we are able to make steam on demand. This part here we call the manifold. Water goes in here on this end, and then using these different valves that you can see here, the water is redirected to one of these places here. You can also see there's our L board, which is now been soldered onto the valves and provides a reuniting point for all the connectors. That's what a pressure sensor looks like, and you can find one here on our manifold so that we can tell the pressure of the espresso puck itself. This is version 1.1 of our electrical board. There's something new on there. You see that big piece of black? That is essentially a electrician's clamp. If you look carefully, you can see that there's a wire going through it. That's our main power. Now, what that lets us do with this version 1.1 machine is detect the actual consumption of each component in the machine. So for example, when you turn a valve on, it should use a certain amount of electricity. But if it's starting to get dirty or clogged up, it's going to consume more. Or if a wire has fallen off, you send electricity to it, the electricity doesn't get consumed. So our circuitry can now detect whether a valve is clogging up, or if a wire is coming loose, or if it's intermittent. Our intent here is to be able to detect most loose wire or clogging or other functional problems before they actually cause the machine to fail completely. And what's more, as a repairman, or if you want to repair it in the field, we can tell you exactly which component is the problem from the firmware. This is our water pump assembly. You've got a hot pump and a cold pump, because the way that the Decent Espresso machine works is it has one hot water channel, which is superheated to about 110 Celsius under pressure, and the other which is room temperature. The way that we're able to get the water temperature you want at any moment is by varying the pulses on these two pumps. And the spring and the rubber parts are so that as this moves up and down, it doesn't make any sound. So this is what the version 1.1 group head looks like, and I'm going to put it on the table here and walk you through it. So one thing to note is our group head has brass here, and the brass part has shrunk by about 20% from the previous model. That's to make it faster to adapt at different water temperatures. Here's water coming in. That's brown because it's going to make coffee. And when the dirty water comes out, it's flashed out as black. This is a cartridge heater, which is mounted in here, and that keeps the whole brass part hot. Our two thermal fuses are now mounted directly to the brass. In the previous versions, they were way back here. Also, we've got a thermostat right next to it. The idea is the thermostat will stop the electricity before the thermal fuses blow. In the EU, you have to have a double safety, and it has to blow permanently, which is what we've done here. Under US rules, you're allowed to recover, which is why we have a thermostat here. And this German-made thermostat is supposed to always interrupt the power before these thermal fuses would ever blow. New to this version, we're now coating this in black. And also you can see here's that group head separator that I showed you earlier, which defines the spacing. What you're looking at here is the electrical engineer station and the repair station. So those machines there are machines that have been sent back to us from customers that were repaired. And now they're refurbished machines so that if a customer has a machine that fails, within 48 hours, we're able to send them a replacement. When UPS shows up to give them the replacement, we take the bad machine back, and then we can repair it a week later and then have it ready for another customer. The most common two causes of machines breaking are one, shipping damage, and secondarily, bad water. Let me show you what shipping damage looks like. So right here, I've got a leg that came back, and you can see it got seriously mangled in the post. We don't really know if some elephant or something decided to sit on it, but that's pretty impressive. Thankfully, these legs come off with just 4 bolts, and we've got a new version now of these legs that are even stronger. Hopefully can withstand even an elephant. This is what the new leg assembly looks like. We've gone from 2mm thick aluminum to 3mm thick aluminum. Number of other changes. On the back here now has a weld across the whole back. The front now has this bend that comes up. And we've also managed to weld these legs throughout the whole front. What now happens is these are welded continuously and then ground down and then painted. And the best thing about these legs is they're fully compatible with the old legs, and all these strength improvements are invisible. The other thing that will break a machine is any gunk in the water, whether it's calcium or cat hair or oil or what have you. Whenever we receive a machine for repair, and this machine here is currently being repaired, we take apart the group head, and one of the things we do is soak it in a solution of Cafiza for 24 hours in order to remove whatever gunk is on the group head parts. It's pretty rare, unfortunately, for customers to clean their own machines, so we always clean them when they pass through here. I'm holding here 4 of our DC board. This is the brain of the computer. It features an ARM processor similar to what you'd find in an Android or iPhone. The most likely thing on a computer to become obsolete is communications. Now currently we're using Bluetooth, but I'm always concerned that in 5, 10, 20 years Bluetooth might not be around. So what we did is we put a connector on the top of the board, and we made it such that the Bluetooth communications or whatever it is plugs into that and can be removed. Now that turned out to be a really good decision because the Bluetooth module that we used in version 1.0 was discontinued, and in fact the company went completely bust. So what we ended up doing is cloning what they had done and making our own Bluetooth module, but adding some smart things to it on top of it since we were there. Our Bluetooth module now has the word decent on it instead of Red Bear Labs because we're the ones making it. It has the same chip from TI and it's fully compatible with all the Red Bear Labs chips that are out there. So who knows, maybe some other companies using Red Bear Labs Bluetooth module will want to buy ours. We also extended the board slightly with some extra pins, and that actually allows you to put a debug port directly in. Those are pins for a serial port. So that opens up serial port control directly to the espresso machine and who knows what. We've also experimentally made a version of this that has Ethernet and Wi-Fi on it. So the idea is we do know that our communications board is pretty future-proof. Something else new on the version 1.1 machines is that we have upgraded to a higher quality flow meter. And this is what it looks like, and it's a complete snap-in replacement. Whereas where the old flow meter was 90% accurate, these are calibrated to be 98% accurate. The company that makes them in 3 different calibrations at 90, 95, and 98%, and of course this is the most expensive one. Any of the version 1 espresso machine owners is welcome to get one of these for free. It'll be part of the update pack if they want to. They unplug the 2 tubes, unplug the wire, snap it in, put it back together, and then they'll have greater accuracy flow metering. And behind me here are the Android tablets that go on top of our machines. And what we do is we leave them charged for several days in order to check out the batteries, and also so that way when we ship the machine, the Android tablet has just been charged, so you can just turn it on with 100% battery. So there you go. There's a tour of the Decent Espresso factory on a Saturday when only Bugs and I are here. I'm really looking forward to next week when we're finally building the version 1.1 machines, starting to ship them out to all the people who bought them. Thanks for being patient, and see you soon.